I'm gonna switch this over to a fake solar system, just so there's nothing else in the background happening. Oh, see, they're already blowing up. Hopefully, it'll run smoother. All right, so we're gonna remake the sun. Sun. You'll also notice that stars actually have like nuclear furnace sound effects in this game. Alright, Venus. Venus goes, let's see if right about here. Okay. Venus, prepare to die. For absolutely no reason. Subsonic wants to see something blow up. I like Subsonic. So, prepare to get hacked. Oh, you can see the trails if you want. That's just going to nuke my computer even faster, though. So let's not see that. We don't need to see trails when there's just going to be a bunch of stuff blowing up anyway. Question is, what's going to happen first? Oh, there we go. There we go. There's some moons blowing up into each other. So let's just take a look at the carnage on just one of our moons here. And yes, when it says moon, every single one of these is a copy of Earth's moon. So like 26 or 27% the size of Venus itself. Alright, so this moon is glowing, as you can see, with that kind of an impact crater. And what does its surface look like? Okay, there's two eyes staring at you at 8,823 degrees Celsius, and the coldest part is room temperature. Composition still looks relatively normal. But yeah, that's happening all over the place. Let's check this one out. This one looks like it's about to... Okay, so this one's like currently about to fuse with moon number 124. Oh my god. This is gonna be amazing. Alright, let's go. Woo! Fusion! Oh, they're bumping into Venus now. Alright, so we have now completely stripped Venus's atmosphere. Like, just like that, Venus has absolutely no more atmosphere. There's nothing to hide from that planet. It is completely exposed. The iron is now liquid. The silicates are now a mixture of solid and liquid, and there's no water or hydrogen on the planet. Look at that, 28,023 degrees. And we're just getting started. Alright, let's go back to the... Wait, which moon am I looking at? This one? Actually, no, let's not look at the specific things. Let's just watch the spectacle unfold. Because, like, let's be honest, if we wanted to look at the specifics of what the heck is going on here, we're going to be here all night. So let's just watch things blow up. Whoa. Whoa! Giant cracks forming on that moon. And again, the music gets more epic as we destroy more stuff. We're forming amalgamations of moons. I think the moon that we're following just got kicked out of the entire system. Moon number 137 might actually survive this. Unless, of course, it pumps into moon number 132. Yeah, I guess so, because, like, it looks like that's what was happening, except now we're getting kicked out. So these other moons are blowing up. And, like, becoming comets. Just, ooh! Just, like, outgassing so much of the material because, like, when impacts of this magnitude happen, Venus is getting struck by a bunch of debris. There's fragments that are just striking the planet now. Oh, they barely missed each other. The thing with this is, like, there's no bias. There's no fallacies because all these moons are exactly the same size. So, like, when we see them pass each other, we know how close they are. Disco moonballs, yeah. I think I'm more interested in the random moon that I picked because it looks like we're actually gonna survive this. Well, real quick, let me check the orbital parameters and see if we're in a hyperbola. If we're in a hyperbola, then we're probably gonna make it out of here. They're on Rochelo, which is very small. Huh, impacting objects. Oh wait, we're orbiting a different moon now. We're orbiting 132. Which I did mention. So if we're orbiting 132, then 132 is probably orbiting us. No, 132 is orbiting Venus. Okay. Well, there you go. Moons can orbit moons. Just, like, pretend that this system is even remotely stable. The eccentricity is 0.970. That's really, really close to a parabola. But it's just a really, really elongated ellipse right now. So we're not quite out of the woods yet. Alright, resume. Oh. Ooh! 4 moons blowing up. Moon 4's got a really nice outgassing going on. It kind of is a battle royale, and unfortunately Venus is not exactly a spectator. Some of the moons actually do accumulate some more mass, and they can grow larger than the others. And it's not impossible that, like, one of these moons will actually become bigger than Venus. I don't know if we're actually going to see that, though. Whoa, one of the moons... Moon number 62 nearly struck Venus there. And the fact that moon number 62 went behind Venus says that moon number 62 is getting awfully big. Okay, so our radius right now is 1,963 kilometers. Venus has a radius of 5,818. 62 has a radius of 2522. So, like, yeah, some moons are bigger than others. 132 is... I think 132 is unscathed throughout this entire operation. And it's still at 1,223. Oh, you want to see the temperature? Alright, well, let's check on 62 first of all. Because that one's blowing out a ton of hot air. Look at that. Look at that. Alright. Oh, that's so cool looking! So, like, basically these are massive flood basalt provinces or something that are developing. The maximum temperature is actually not too insane compared with the rest of the planet. It's only 3,552 degrees, which I would have thought is a little bit larger. But, like, the coldest parts are 324, which is still, like, basically impossible. Yeah, I basically gave it molten continents. Alright, let's check out Venus. Wait, first of all, let's check out this one. This moon looks normal. It is normal. So, like, that's what a normal world should look like here. 147 should be normal too. No! I was wrong. Moon 147 has been hit. Alright, Venus. Wait, no, Moon 3 looks pretty exciting. That one's blowing out some steam. Look at that. So, like, all of these have pretty much unique temperature gradients at this point. 48's looking pretty interesting. Oh, it's a screaming face! With one eye a little bit further out than it should be, but it's a screaming face. It's horrified by what I'm doing to it. Alright, Venus. That's more like it. Okay, so, like, obviously across the equator we can see where all the fragments are hitting. Like you said, like, the sphere is kind of devolving into a ring, and when it does, the fragments keep on striking Venus near the equator, and that's a spot where one of the moons just directly hit it. Alright, let's go back to our world. Not much there. Alright, oh, we did it! We're orbiting the sun now! We're gonna make it out of here. And with a relatively stable orbit, too. Alright, so our randomly selected moon's gonna make it out of here alive. Maybe a little. I might be slightly hungry, I don't know. Alright, where's 90 going? Looks like 90's gonna make it out alive as well. Oh, Venus is still getting struck by a bunch of debris. Oh boy. Whoa! Whoa! Whoa, what is this moon doing? Moon number 123. It's spewing out a crap load of its own matter. It looks kind of interesting. What's its mass loss rate? It's like it is spewing out so much of itself. Wow. Alright. 1.26 trillion kilograms per second. That's how much mass it's spewing out here. Alright. Sorry, number 137. I gotta take a closer look at this. Look at that. We can actually orbit the fragment, too. Oh, that looks kind of cool. It almost looks like obsidian. Which is kind of appropriate because, A, the moon is made of basalt, which is a volcanic rock, and B, the things are just happening so fast that theoretically, if any crystals could have formed from like instantaneous shock metamorphism, they wouldn't, because these processes are just crazy. Wait, what is E to the 4th? You mean like 55.4 something? And some of these fragments are on fire. Like this guy. Moon number 44 is kind of turned pink. At least from this angle. Alright, let's see how number 123's story plays out here. Oh, whoa. There's a tiny moon. Moon number 107 here has lost so much of its mass. It's down to 799 as far as its radius. Oh, the mass loss? Whoa! Look at these continents. Alright, mass loss rate for moon number 107. Actually less than the last one? Okay. Half iron, half silicate. Is that what it's supposed to be? Well, this one looks pretty unscathed. No, that's what it's supposed to be. All right, let's check out Venus again. Specifically, what's its mass loss rate right now? 198! Venus is somehow only losing 198 kilograms per second. You tell me how exactly, because because it's still just being constantly battered by debris. Uh-oh. Here comes a direct hit. Moon number 131 is going to hit it. Oh, never mind. Uh-oh. Moon 128 and 130... 128 and 113 have fused. 128 no longer exists. Ooh, these are cool patterns. Yeah, I wanted to save something like this for the grand finale. Oh, fragment. Alright, so 113 here. What does it look like? Oh, yeah, we just did that, didn't we? I'm curious what its orbit is supposed to look like now. No, it's still almost believable. Uh-oh. Uh-oh. Don't hit it! Don't hit it! No! Whew! Uh-oh. Whoa! It came so close to smashing into Venus. Like you can see how its momentum just totally switched at like a 45-degree angle. Like that eccentricity value is way off. Like as soon as this thing actually well, it's not going to stabilize in all likelihood. The patterns look a little bit more intense now. Wait, what was it gonna? Oh yeah, this one. 123 here. There's a huge, just gash of pure death on its surface. Like, the developers had to know. They had to know that the moon sphere was pure unadulterated chaos. Because how could it be anything other than that? I want to check on the moon that we were following from the beginning. Was it this one? This one? 137? Yeah, we're gonna make it. We're not. Well, moon number 90 is kind of following us. But we need to have to get a stable orbit for one of these. Basically get rid of everybody else. So hopefully we get to see that play out a little bit. Wait, what? That's not the right distance. For some reason, this thing thinks that we're only that we're like 1,050,000 kilometers from the sun, and we're not. We're about 100 times that. Curious, like, what's the relationship between 137 and 90, if any? Oh! Moon number 90 is orbiting us now. Let's compare masses real quick. Alright, 3.24 times 10 to the 22. And we are 1.4 times 10 to the 23. So we're about 4 times as massive as moon number 90. So moon number 90 is actually orbiting us now. Or is it? looks about right. It looks like moon number 90 is behaving pretty well for us. So not only is it possible to escape this complete and utter hell, but you can escape it with a friend. I never would have guessed that. All right, moon number 4 is having a rough time here. Moon number 3, likewise. Oh, that's bad. 80,000 degrees in just that one impact. And at no point is it less than 121. Oh, what I should be doing is like looking at the Earth similarity for these just battered and broken down worlds. 18.1% for this one. How about you? You look a little bit less traumatized? Yeah, that's a lot better. 35.1%. Moon number 3 is doing a little bit better. Now I gotta say what Venus is. Where's Venus? Oh no, there's Venus. Moon number 1. I thought that moon number 113 was Venus because it's blowing up just as badly. Alright, how similar is this Venus to 11.6%? 11.6% similar to Earth. I've gotten it way worse than that, just so you know. Anyway, moon number 113. Oh, 18.9. Not much worse than the other moon that I was looking at. Number 4. But if you want to know what the parameters are, a measure of how physically similar a planetary mass body is to Earth based on radius, density, escape velocity, and surface temperature. So these things are all completely burning up, and they're still somehow similar to Earth. In some ways, at least. Alright, let's check out our little moon over here. Oh, this is number 90. Our friend. 42.1, and we are 50.4. Wow, I really did pick the right moon. Somehow we're over 50% Earth similarity over here. So I picked a great moon. Is there any moon here better? If it's anything, it has to be one that's already escaping. Oh my god, moon number 9 is great. 60.6% somehow. Now, granted, they all still have 0 life likelihood because there's no, there's no water. All right, we gotta check out this interaction between 4 and 3 here.
I said you can do
Whoa!
piano, but you
That startled me.
do nothing.
Oh, 4 and 3 orbiting each other. Oh shoot! 119. 96. Okay, so 4 and 3 have nothing to do with each other now. This is so crazy. Who's gonna be the last one standing? Is Venus even going to be the most massive object here by the end of this? Oh, 96! Just got broken up by 62. But it still exists. Let's check it out. And with 43.4 similarity? What? What's 62 look like? A lot worse. Well, first of all, 96 looks awfully small. No, that's about normal for the moon. I think. Maybe a little bit less. The winner of the Battle Royale earns an atmosphere? Yeah, we can do that. We can try that at least. 62 is a lot bigger. Yeah, 25-27. What's Venus again? 58-43. So yeah, both the iron and the silicates are molten now. Like, everything on Venus is now a liquid. Random molten fragment of these guys' collisions. But 86 looks interesting. Trying to hide, trying to hide all those burn marks I see. Well, that's not so bad. All right, let's take a long, like a wide angle view of the whole system. So like, we've got a decent number of ejections going on now. There's a lot less chaos. But at the same time, there's a lot less order because, like, instead of having a sphere or a ring, they're just all kind of there. I sped the things up a little bit. Yeah, they're not hitting each other quite as often. Oh, there we go! 113 is huge. And looks pretty cool there. Oh, yeah, 113 is actually getting nearly halfway to the size of Venus. Uh-oh. Unfortunately, it seems to be losing a lot of that mass. Oh no, it's gonna lose a lot more than that. Oh no! Oh, it survived that. I thought it was gonna hit Venus. Oh, but it might hit 62. Nope, nope, they missed each other as well. Moon 11 nearly hit Venus. Oh, they're going back for another round. 113. Oh, 113 strikes Venus. And somehow Venus is not completely vaporized. I mean, that was an object half its size, and somehow Venus took that. Venus took that. I don't know how. But like, that was a collision with a body that was half its own size, and somehow it's still in one piece. How? How? Look at that mass loss rate, 202. How can you only be losing 202 kilograms per second after that hit? How long am I on? Oh, okay, I got a little bit longer. Although the other thing that Subsonic wanted to see was a supernova. Ooh! Whoa! Moon number 4 has been defeated. Moon number 4 just got broken into a bunch of tiny shreds by passing so close to Venus. Like, this moon actually has a ring around itself because of that collision. Like, it has its own ring. Like, how small is it now? Not bad, actually, but, like, what's its mass loss rate? Yeah, that's pretty bad. And it's getting worse. Because the ring is actually hitting itself now. Its own, like, it ripped apart and then gathered its own pieces back somehow. Venus, why are you not dead yet? Alright, I think moon number 4 is fine now. Let's check in on the two friendly moons, 137 and 90. There we are. See, we're still friends. Everything worked out fine for these guys. So there's a happy ending here. In fact, I'm going to save this, and I'm going to call it 137 and 90's happy ending. From a Hellzone grenade of moods, again going back to my Dragon Ball, my Dragon Ball roots. So that's basically what that was, is a Hellzone grenade from Piccolo. $137 and 90 have a friendship that'll last them forever, or at least for. Well, they should be good because like 137 has a pretty good orbit around the sun now, right? Let's zoom out here. Let's take a look at the orbits. Okay, so we're not the only ones to have made it out, but 90 has a pretty nice orbit around us, and we have a pretty stable orbit around the sun. So it all worked out. Yeah, yeah. They wanted absolutely no part of this. Maybe if I speed up time by a ton. Maybe there's going to be some more conflict between the moons that actually got out with their skins intact. But I don't know. Alright, what should I do next?